In the farthest reaches of our solar system, where sunlight is a faint whisper and planets drift in near-eternal twilight, something extraordinary unfolded. The James Webb Space Telescope, humanity's most powerful eye in the cosmos, turned its gaze toward Neptune, the enigmatic ice giant, and captured a moment of cosmic violence that left astronomers speechless. A massive object, perhaps a rogue comet or an icy wanderer from the Kuiper Belt, had collided with Neptune, sending shockwaves through its swirling atmosphere and leaving a chemical scar visible in infrared light. This wasn't just a fleeting spectacle, it was a rare window into the dynamic, ever-changing nature of our solar system. So grab a seat, hit that like button, and subscribe for more cosmic journeys as we dive deep into this monumental event and what it tells us about Neptune, our solar system, and the universe beyond. Neptune, the eighth planet from the Sun, has always been a world of mystery. Nearly 30 times farther from the Sun than Earth, it's a faint speck in even the most powerful ground-based telescopes. Its deep blue hue, caused by methane-absorbing red light, gives it an otherworldly beauty, but its distance, about 4.5 billion kilometers from us, has kept it elusive. Voyager 2's flyby in 1989 offered our first close-up glimpse, revealing a turbulent world of supersonic winds, massive storms like the Great Dark Spot, and a delicate system of rings and moons. Since then, studying Neptune has been a challenge, with its faint light and Earth's atmospheric interference limiting what we can see. But the James Webb Space Telescope, orbiting far from Earth's distortions at the L2 Lagrange point, changed everything. Its infrared vision pierced Neptune's veil, revealing not just the planet's icy clouds and faint rings, but a sudden dramatic event, a collision that shook the ice giant to its core. To grasp the scale of this event, let's paint a picture of Neptune itself. This is no small world, with a diameter nearly 4 times Earth's and a mass 17 times greater. Neptune is a gravitational titan, dominating the outer solar system. Its atmosphere, a thick brew of hydrogen, helium, and methane, swirls with winds that can hit 1,400 kilometers per hour, faster than anything on Earth. Beneath this lies a mantle of water, ammonia, and methane ices, compressed into exotic states under immense pressure. When Webb's data streamed in during the summer of 2025, it showed a sudden spike in thermal emissions and unusual spectral lines, signs of a massive impact. The intruder wasn't a mere pebble. Estimates suggest it was tens, perhaps hundreds of kilometers across, potentially the size of a small moon. The energy released as it slammed into Neptune's atmosphere was staggering, equivalent to millions of nuclear explosions unfolding in an instant. Unlike impacts on rocky planets like Earth, where craters mark the surface, Neptune's collision played out in its gaseous depths. As the object plunged through the atmosphere, it compressed the gas ahead of it, creating shockwaves that rippled outward at supersonic speeds. The intruder didn't just crater, it disintegrated, dissolving into Neptune's hydrogen-rich seas and scattering exotic materials, possibly ammonia, carbon dioxide, or complex hydrocarbons. Webb's near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, detected these chemical fingerprints, revealing carbon-based molecules and ices not typically dominant in Neptune's atmosphere. This chemical scar could linger for decades, a ghostly reminder of the collision. For astronomers, it's like finding a cosmic crime scene, with clues about the impactor's origins scattered across Neptune's skies. What makes this discovery so thrilling is its timing. Collisions of this magnitude on Neptune are rare, likely occurring once every few centuries or millennia. That Webb caught it in real time is a stroke of cosmic luck. The telescope's ability to resolve fine details in infrared allowed it to spot transient bright spots and disturbances in Neptune's cloud bands, telltale signs of the impact's aftermath. These features, unlike the planet's usual storms, appeared to twist and elongate in unique patterns, suggesting the collision stirred Neptune's already chaotic atmosphere into new forms of turbulence. Imagine dropping a stone into a stormy ocean. The ripples don't just fade, they interact with existing waves, creating unpredictable patterns. This is what Webb saw, a planet reshaped, however subtly, by a moment of violence. This event isn't just about Neptune, it's a glimpse into the solar system's ongoing evolution. We often think of our cosmic neighborhood as a settled place, with planets gliding along predictable orbits. But the outer solar system is a restless frontier. The Kuiper Belt, a vast ring of icy bodies beyond Neptune, is a reservoir of potential impactors. Gravitational nudges from Neptune itself, or even distant stars passing far beyond the Sun, can destabilize these objects, sending them hurtling inward. The impactor Webb detected might have been one such wanderer, dislodged from its orbit and drawn into Neptune's grasp. This reminds us that the solar system is not a museum of static relics, but a living system, where collisions still shape worlds billions of years after their formation. The collision also offers a rare chance to study how impacts affect gas giants. On Earth, impacts have left indelible marks. Think of the Chicxulub crater, linked to the extinction of the dinosaurs. But gas giants like Neptune, with no solid surface, handle impacts differently. The energy from the collision penetrated deep into Neptune's atmosphere, possibly disturbing its layered structure. Beneath the visible clouds lies a mantle where water and ammonia exist in strange superionic forms, neither fully liquid nor solid. The impact's heat and momentum could have disrupted these layers, altering convection patterns or even the planet's magnetic field, which is already tilted and offset in ways that puzzle scientists. Webb's ongoing observations may reveal changes in Neptune's auroras or thermal emissions, offering clues about its enigmatic interior. For exoplanet researchers, this event is a goldmine. Many of the thousands of exoplanets discovered are gas or ice giants like Neptune orbiting distant stars. Their atmospheres, studied through starlight filtering through their skies, often show puzzling features, unexpected chemicals or temperature spikes. Could impacts be the cause? Neptune's collision provides a real-time case study. The spectral signatures Webb detected, carbon enrichments, exotic ices, could mirror signals from distant worlds. By building a library of impact-related signatures from Neptune, astronomers can better interpret exoplanet data, distinguishing between steady-state atmospheres and those altered by sudden events. This makes Neptune not just a planet, but a Rosetta Stone for understanding alien worlds. The impact also touches on planetary defense, a topic closer to home. Earth is shielded by Jupiter and Saturn, which act as gravitational vacuum cleaners, sweeping up many wandering objects. Neptune's collision shows that even distant giants bear the scars of cosmic impacts, highlighting the protective role of these planets. By studying how Neptune absorbed this impact, scientists can refine models of how objects move through the solar system and estimate the risks to Earth. The impactor's path, likely influenced by Neptune's gravity or resonances in the Kuiper Belt, offers data for predicting similar events closer to home. NASA's Planetary Defense Coordination Office, tasked with tracking near-Earth objects, will likely draw on this event to improve its simulations. Neptune's moons and rings add another layer to this story. The planet's largest moon, Triton, is a captured Kuiper Belt object, its retrograde orbit a clue to its violent past. The collision might have sent debris into orbit, subtly altering Triton's icy surface or even its orbit over time. Neptune's faint rings, made of dust and ice, could also have been affected. A surge of material from the impact might have fed these rings, brightening them or creating new arcs. Webb's infrared sensitivity could soon detect such changes, offering insights into how rings form and evolve. This echoes questions about Saturn's rings, which may owe their brilliance to similar catastrophic events. Neptune's collision thus becomes a live experiment in planetary architecture. The chemical aftermath of the impact is equally fascinating. The impactor likely carried materials from the solar system's outer reaches, frozen gases, organic compounds, or even rare isotopes. As it disintegrated, these mixed with Neptune's atmosphere, creating a natural laboratory for studying the chemistry of the Kuiper Belt. If the impactor was a comet, it might have brought complex molecules formed in the solar system's infancy, offering a glimpse into the conditions that birthed the planets. Webb's ability to detect molecules at parts per billion levels makes it possible to analyze these chemical gifts, turning Neptune into a time capsule of the early solar system. This discovery also challenges common misconceptions about the outer planets. Many assume Neptune is a static, unchanging world, too distant to matter. Yet this collision proves it's a dynamic place, shaped by the same forces that sculpted Earth. Another myth is that impacts are purely destructive. While they can wreak havoc, they also deliver materials, stir atmospheres, and drive evolution. The dinosaurs may have perished because of an impact, but Earth's water and organic molecules likely arrived via similar cosmic deliveries. Neptune's collision reminds us that destruction and creation are two sides of the same coin, a duality that defines the cosmos. The philosophical weight of this event is profound. Neptune, named for the Roman god of the sea, has long captured our imagination as a distant, untouchable world. To see it struck by a massive object, its atmosphere rippling under Webb's gaze, is to feel the universe's raw power. It's a reminder that the cosmos is not a serene backdrop, but a place of constant motion, where worlds are forged and reshaped in moments of violence. For humanity, this event is both humbling and inspiring. It shows our ability to witness cosmic dramas billions of kilometers away, thanks to tools like Webb, while underscoring how much remains unknown. As scientists continue to analyze Webb's data, new questions emerge. Some spectral lines don't match known compounds, hinting at exotic reactions between the impactor's material and Neptune's atmosphere. These could reveal new molecules or processes unique to ice giants. The thermal glow from the impact lingered longer than expected, suggesting energy penetrated deeper than models predicted, perhaps into Neptune's superionic mantle. These mysteries will fuel research for years, as astronomers use Webb to track changes in Neptune's storms, rings, and magnetic field. Each observation adds to a growing picture of a planet in flux, caught in the act of transformation. This collision also makes a case for future missions to Neptune. Voyager 2's brief visit left us with more questions than answers, and Webb's discovery underscores the need for a dedicated orbiter. Imagine a spacecraft circling Neptune, mapping its atmosphere, moons, and rings in real time. Such a mission could study the impact's long-term effects, new storms, altered orbits, or chemical shifts, while probing the planet's interior. NASA and ESA have discussed concepts like the Neptune Odyssey mission, and events like this could push them forward. The outer solar system, often overshadowed by Mars or Jupiter, deserves a closer look. For viewers like you, this discovery is an invitation to wonder. What other secrets does Neptune hold? How many collisions go unseen across the galaxy? Share your thoughts in the comments below, and don't forget to like and subscribe for more space adventures. This event reminds us that the universe is alive with change, from the birth of stars to the clash of worlds. Neptune's collision captured by Webb is a chapter in that story, a moment of chaos that reveals the beauty and complexity of our cosmic home. As we continue to explore, tools like Webb will keep pulling back the curtain, showing us that even the farthest planets have tales to tell. Keep looking up and let's uncover the universe together.